Hello everyone, welcome to another presentation about DP transmitter calibration. Before we dive into the topic, there is a question that begs our attention. What is a pressure transmitter? A pressure transmitter is any device that is used to measure the pressure of a fluid. Another related question is the difference between a transducer and a transmitter. Now, if you ask 5 different people this question, you're bound to get 5 different answers. But one of the most commonly accepted differences are as follows. A transducer is any device that is used to transduce or change one form of signal into another form of signal. Whereas a transmitter is a device that is used to amplify the signal in order to transmit it or send it over long distances. Now, the amplification is done in order to avoid loss of signal while it is being transmitted. Another difference is that a transducer is a voltage output device, whereas a transmitter is a current output device. You will normally get your transducer output in millivolts, whereas your transmitter output will be in milliamps. Now, the figure you see in front of you is that of a typical pressure transmitter. This transmitter has 3 ports, that is, an isolation valve, a vent valve, and a drain plug. The isolation valve is used to isolate the pressure transmitter from the process system. The vent valve is used to vent or depressurize the pressure transmitter, and the drain plug is used to remove the remaining fluid present in the pressure transmitter. Normally, the pressure transmitter is normally connected to a line which contains the fluid whose pressure or flow is to be measured. This figure shows the image of a typical pressure calibrator with its tubing and its attachments at its two ends. The figure you see in front of you is basically the connections involved for calibrating a pressure transmitter. As you can see in the extreme left, there is a pressure calibrator which is connected to the pressure transmitter through the tubing along with its attachments via the drain port of the pressure transmitter. We also use a digital multimeter in the milliamp mode, wherein the red port of the multimeter is connected to the negative of the pressure transmitter, and the black port probe is connected to the negative of the 24-volt DC supply. Now, before we actually get into the pressure calibration of the pressure transmitter, there are a few steps that need to be done. Now, these are very important because it is related to the safety of the personnel involved. The number one step to be done is filling the permit to work properly and obtaining the permission to work on the system. After doing that, we need to ensure that appropriate lockout tagout has been done on the system. Then we need to conduct a thorough toolbox meeting, ensuring that people involved are thoroughly informed of the job to be done and also the risks and hazards involved. Also inform them of the PPE required in order to do the job. Once all this is done, we are ready to calibrate the pressure transmitter. Now, like I said, normally a pressure transmitter is connected to a line. Now, the line will have a main isolation valve, which is also called as a process isolation valve. We first isolate or close the process isolation valve and then proceed to close the isolation valve of the pressure transmitter. Thus doing, we isolate the pressure transmitter from the process system. After doing that, we open the vent valve, thus depressurizing the pressure transmitter, and then open the drain plug in order to drain the remaining fluid present in the pressure transmitter. After doing so, we take the tubing along with its attachments and connect one end of the tubing to the pressure calibrator and the other end through the attachment via the drain plug of the pressure transmitter. As already mentioned, we already have a multimeter in the milliamp mode connected to the pressure transmitter negative terminal through the red probe, and the black probe of the multimeter is connected to the negative terminal of the 24-volt DC supply. We also need a typical calibration chart that is normally provided by the manufacturer. The calibration chart you see in front of you shows the 5 different pressures that are to be applied and the respective output in milliamps that will be given by the pressure transmitter. Now, this is basically 5 different steps involved in the test. The first step will be applying 0 pressure. Second step will be applying 25% of the pressure, which in this case is 62.5 kPa. Third step is 50%, that is 125 kPa, so on and so forth, and up until you reach 100% of the pressure, which is 250 kPa. And for each pressure, you will be getting a corresponding milliamp output from the pressure transmitter, which can be read off the multimeter. Now, as you apply each pressure, we record the measured output and we compare it with the supposed output that is supposed to be obtained. If there is a considerable difference between the applied pressure and the measured pressure, then we proceed to do the necessary adjustments. There are two types of adjustments that can be done. One is a zero adjustment, another is a span adjustment. Zero adjustment is done at 0% of the pressure, wherein you apply 0 kPa pressure through the calibrator to the pressure transmitter. And at this point, you're supposed to get at the multimeter milliamps of 4 milliamps. If the pressure transmitter is showing a different value, you're supposed to adjust it using the zero knob present in the pressure transmitter device until you get a value that is very close to 4 or 4. Once that is done, we proceed to do the span adjustment, wherein you put 100% of the pressure, which in this case is 250 kPa, and in this particular example, you're supposed to get a milliamp output of 20 milliamps at the multimeter display. Again, if there is a considerable variation in the display from 20 milliamps, what we do is we adjust the pressure transmitter using the span knob present in the pressure transmitter backside. Once the adjustment is made and we bring the value to 20 milliamps, for this particular example, we are done with the zero and span calibration. Now all that is to be done is bring back the pressure transmitter to its original condition. How we do that? Well, it's very simple. We just bring back the pressure back to zero using the pressure calibrator. Open the drain plug slowly. Then open the drain plug slowly to remove the tubings along with their fittings. Close the drain plug. Close the vent valve fully. Open the isolation valve fully. And then put the pressure transmitter back onto the process system. Then finally we open the main isolation valve of the process system and put the pressure transmitter back in use. I hope this video has been of use for you and you have understood what I have tried to convey. If there is any doubts or questions, please don't hesitate to put it in the comment section. Before I move away, I would like to thank every one of you for your positive input for my previous upload. It was because of your positive response that I was motivated to put another video like this in YouTube. Thanks. I request your constant support again. I hope you have a nice day. Thank you.